Hey everyone, welcome back to Roboarmy, where ideas turn into real working projects. Today's project is something really exciting. We have built a touchless musical instrument using ESP32 and ultrasonic sensor. Yes, you heard it right. You don't need to touch anything. No button, no keyboard, no strings. Just move your hand in the air and music plays. This project is perfect for learning sensor, real-time sound generation, embedded systems. So let's dive into it. Now to build this project, you will need one ESP32 development port, 7 ultrasonic sensor HCSR04, jumper wires, breadboard, 1 speaker or Arduino output, micro USB cable, PAM8403 audio amplifier, DC 5V connector for external power supply through connector. Make sure you use a stable power supply because multiple sensors are involved. Now let's connect everything step by step. Ultrasonic sensor connections. Now each sensor has trig pin, echo pin, VCC and GND. Connect all VCC of all sensors to the positive power rail on the breadboard and all GND to the negative power rail. Now for signal pins, connect the pins as follows. Sensor 1, trig pin to GPIO 14, echo pin to GPIO 34. Sensor 2, trig pin to GPIO 12, echo pin to GPIO 35. Sensor 3, trig pin to GPIO 13, echo pin to GPIO 4. Sensor 4, trig pin to GPIO 15, echo pin to GPIO 5. Sensor 5, trig pin to GPIO 2, echo pin to GPIO 32. Sensor 6, trig pin to GPIO 18, echo pin to GPIO 33. Sensor 7, trig pin to GPIO 19, echo pin to GPIO 27. Now for sound output, connect positive pin of speaker to the positive L out of PAM8403 audio amplifier, negative pin of speaker to the negative L out of PAM8403 audio amplifier. There uses ESP32's internal TSE to generate audio. Now connect the positive power of the PAM8403 audio amplifier to the positive power rail and negative power to the negative power rail of the breadboard. Then connect the input pin of the amplifier to GPIO 25 of USB. Before moving ahead, double check the connection through the circuit diagram. Now download the code file from the description below. If you don't have Arduino IDE installed, install it first. It's very important. Now open the code. Let's understand everything step by step. Now at the top, we include liquid libraries. Mozzi for audio synthesis, Oscill to generate waveform, ADSR for smooth sound, NewPing to read ultrasonic sensors. Now each library plays a critical role. We force ESP32 to use internal DAC. This allows direct analog sound output without extra hardware. Now we define control underscore rate for speed of control loop, max underscore distance for max sensor range, threshold for detection limit. This controls responsiveness and accuracy. Now we define 7 nodes C, D, E, F, G, A, B. Each sensor is mapped to one node. Now sensor pin setup. We define trig and echo pins for all 7 sensors. Then we create new ping objects for each sensor. This allows us to read distances from all sensors. Now envelope ADSR. We define sound shaping. Attack for how fast sound starts, decay for slight drop, sustain for level hold, and release for smooth fade. This makes it sound natural instead of harsh. Inside setup function, initialize envelope, set oscillator frequency to 0, start Mozzi engine. Everything is prepared before the loop starts. Update control function. This is the brain of the system. Here's what happens. Envelope updates continuously. It checks if node duration is finished. It releases the node smoothly, then scan all sensors. Sensor detection logic. Now for each sensor, measure distance. If distance less than threshold, it activates. To avoid noise, we use counters. Octave logic. Distance control pitch. Near low pitch for high pitch. This creates dynamic music. Node triggering. When a valid detection happens, frequency is calculated, oscillator is updated, and node starts playing. Update audio function. This generates real sound, gets waveform, applies envelope, outputs final audio. Now inside loop function, we call audio hook function. This keeps everything running smoothly without a delay. Now let's upload the code. Connect ESP32, open Arduino IDE, select tools, board and ESP32 dev module, Select correct COM port, then click upload. If it gets stuck, press and hold boot button. Now make a structure using cardboard like this. Now before testing, check this. Before running the project, check wiring is correct. Sensors are powered properly. Speaker is connected to DAC pin. No loose connections and the power supply is stable. Now let's see how it works. Now as soon as ESP32 starts, system initialize, sensors begin scanning, audio engine starts. Now move your hand near any sensor, you will hear a musical note. Move your hand close or further, pitch changes in real time. Move across sensors and different notes play. Now live demo. Hand near sensor, note plays. Move hand, pitch changes. Switch sensors, different notes. No touch, no delay, pure interaction. This is not just a fun project. You have learned ultrasonic sensing, real-time audio generation, embedded signal processing and interactive system design. This is how real electronic instruments work. And that's it for today's project. Your touchless musical instrument is ready. If you enjoyed this, like, share and subscribe and comment your next project idea below. Because here you ask, we build.
Roboarmy. One-stop global community for teens in robotics and AI.